My name's Ethan Bogert. This is Project 2. So we're going to first start out by opening up ANSYS and starting our project with Fluid Flow Fluent. Once we open up the Fluent, we'll start designing our geometry. Start sketching out our pipe. Start with a basic rectangle. All right, once we have our rectangle, it's going to quickly do some measurements on it. So given that we have to use an equation of L equals 150 times the height, I'll make my height in a way so that my length is 1.5 meters. So that means my height is going to be, let me just quickly do that real quick. Comes out to 1/100 of a meter. So with these measured out, I'm just going to add my dimensions real quick. It's 1.5 meters and then 1/100 of a meter. It's going to be a very long yet thin pipe. Once we have this pipe, I got to make it into a surface. So go to concepts, surface and sketches, and then I'm going to do it based off of the lines. So just got to zoom in here. And then using the select tool and control, I can select multiple lines. And with all my 4 lines collected, hit apply. And then just need to do generate. And there's my pipe. Alright. So that's all we have to do for the geometry. So we're going to go back here, update, just make sure everything's saved properly, and then we're going to go into our mesh. Once our mesh loads, we're going to start off by just naming our surfaces. So in this case, we're going to have 4 separate surfaces: our upper wall, lower wall, inlet, and outlet. All right. So I'm just going to click here, press N. This is going to be my upper wall. Same thing down here. This will be my lower wall. This will be my inlet. And this will be my outlet. Alright, and just to verify, name selections, upper wall, lower wall, inlet, outlet. Perfect. Alright, then we're going to go to our mesh. So we'll start out by doing a sizing mesh. And I'm going to geometry select my top and lower wall. Apply. I need to make sure that this is not element size and that this is number of divisions. Since I have 1.5 meters, I'm just going to do 1500 because that seems like a nice number for that. Go down here to capture curvature, hit no, and set this to hard. And then we'll insert another sizing mesh. This time my inlet and my outlet. Apply. And same thing over here. Set this to number of divisions. And this one we're just going to do 100. Now, same thing. Capture curvature, no. And set this to hard. And then I'm going to generate my two meshes. So it'll take a second. Oh, looks like we've got an error. Let's try this real quick. It looks right. So then we just have to do one more mesh. Do insert. Actually, now what we're going to do is go to mesh, face meshing, select the space, apply. All that's fine, and generate. Verify that mesh should be nice and dark up until you get really close. So I've got a super fine mesh on this, which looks about right. And then just to verify, my endpoints should be a little bit more fine than the rest. Just check that down here. Let's see. Whoa, what did it do? There we go. Yep, perfect. Alright, so that's the mesh complete. And go ahead and update this. And now we can go right in the setup. So make sure you double precision JAWS, use two solvers, and go ahead and start. Alright, perfect. Now this is loaded. The first thing we need to do is set our model to laminar. Go ahead and do that. And then because we want a Reynolds number of under 2500, I'm just going to keep my air's density the same, but increase its viscosity to 3n to negative 0.5. So a little less than double. And we'll do change/create. And just to verify that's saved. Perfect. Yep. Now that we have our fluid, going down to our boundary conditions, inlet, we have an inlet velocity of 5 meters per second. Let's go ahead and apply that. And we have an outlet condition at 0 gauge pressure, so that's all fine and dandy there. Then we'll go to internal. Nope, not internal. Sorry, walls. Our lower wall is moving at -2 meters per second. So we'll go ahead and do a moving wall. And the positive x direction, so need to do that as negative. I could also swap that to -1 and do that as 2, but just a little easier to just throw a negative there. Go ahead and apply. And then I need to do my upper wall, which is moving up 3 meters per second. Same thing here. Go ahead and throw this at 3. Apply. Close. So that's... Where's my mouse? What did I do? Oh. There it is. Alright, found it. Alright, so we have our length, height set, Reynolds number set, laminar flow set. Velocity set. So that should be everything. We can go ahead and start our initializations. Go here. Initialize. I'll run a calculation. Let's set this to 1,000 iterations, but this should converge before then. But we'll go ahead and find out. Yep, perfect. Right where I expected it to. Just look at this real quick. We have it converging at about 55 iterations. Which is what I had last time. Looks like we're making the same progress. So, now that we have everything set up, we can go ahead and start looking at our contours. So, the first contour we're looking at is our velocity contour, but specifically with vectors. We'll go down the results, go to graphics, vectors, do velocity, velocity magnitude, that's all right. I found the 1 scale is pretty good, but skipping, I believe I said 2 works a little better. I'll go ahead and fiddle over that until I like it, but select all my options. Don't know why nothing's appearing. Oh, there we go. I don't know why it was so zoomed out. Go towards the beginning. So we can see that developing region starting to form as that boundary thickness grows. We see the reversal here from the moving plate backwards as it increases, and we get up to 5 here. So everything looks right. I'm actually going to drop that back down to 1, see how we look. Yeah, that looks a little better. So we'll go ahead and do that. Zoom in a little bit more so you can see that. There we go. Alright, so I'm going to save this as my velocity contour. Yep. And then I need to show my pressure contour, so we'll go ahead and go contours. Name this one pressure. Do static. All my options. Save and display. Zoom out. So as expected, we're seeing from high pressure to low pressure throughout the pipe, which is what we should be expecting. So that's looking all great. And of course, since static pressure is dropped down here, we'll have higher dynamic pressure, lower dynamic pressure down here. I don't need to do it, but I'll go ahead and show it anyway. This should go blue, this should go red. Oh no. Kinda. Partly right. Doesn't matter. Vector setting. Yeah, that's what actually matters. Go ahead and leave it like that. So that's that contour done. Next is velocity profiles. So I'm going to go down to my plots, do an XY plot. This one I have to swap to 0 and 1 just to get the directions right. Go ahead and put our position on our y-axis, and then we'll do velocity, velocity magnitude. And I need to do new lines. So one in the midline, which would be my x value at 0.75, and then same thing over here, 0.75, and then 0.01. And great. Oh, I named that line 6. I'm just going to do a second one named midline. There we go. And then now we need to do our end, which all we're going to change here is up this to 1.5 and up this to 1.5. and then we'll create. So there are 2 extra lines that we needed. So now ahead with all this set up, I'll just set this to my mid and my end and save and plot. So right now we're seeing that the flow is having this little curve right here. To go ahead and fix this just to make it so this hits -2 like we're expecting towards the end of that bottom plate, and just swap it to X velocity and save and plot. There we go. That's what we more expected. Velocity increases as we go up. We hit a maximum towards the middle of the pipe and back down to the expected 3 velocity of the top plate. So we should have just about 7 here because of the pressure differences. Yep. All right. So we've got our pressure contour, our velocity contour, our velocity profiles. Now that's all I can do from this end. So I can go ahead and go into my CFD. Gotta load this up. And what we'll do is we'll go ahead and go Tools, Function Calculator. This is going to be... No, I did this wrong. Sorry. So let me insert location point. This one named max. Right, and then we're going to do all domains instead of method, we're going to do variable maximum. I need to do my surface body. We're going to do velocity. And then hit apply. This should put it right towards the end. Yep, right there. Go up here. Go ahead and probe this variable. So right now we're seeing that our maximum is at 1.44591 meters. And then to get my maximum velocity, just have to hit here. We get 6.77567. That doesn't seem right. Hold on. That's the right position. But I'm going to go ahead and go back here to get my maximum. So I can go ahead and go to results, do a surface integral, do my vertex maximum, velocity, X velocity, and do my interior surface body. And compute. There we go. 7.297,294, which is what we expected. Yeah, based off this. Yeah, that's more like it. Other than that, determining the pressure gradient using the fluent result, which is part E, the last bit of this. I'll go ahead and have that attached in the project report. Thank you.